and welcome to our live session today. My name is Erika, and I'm excited to be talking to you today about the 5 most common data sufficiency mistakes and giving you my top tips for avoiding traps on data sufficiency questions. So we're going to be talking about the 5 most common data sufficiency mistakes. And with each mistake, we're going to be talking about my tips for avoiding the traps associated with those mistakes. So when people make mistakes, it's because they've fallen into a trap intentionally laid by the test maker. So we're going to learn what those mistakes are, learn what those traps are, so that we can walk around them on test day and not end up in a situation where we're missing questions that we shouldn't otherwise miss. Now, before we do that, just a quick introduction to who I am. My name is Erika Tyler-John. I am the Senior Education Manager at Magoosh. So I'm here representing Magoosh GMAT today. Okay, so what are we talking about today? Thank you, Vedanj. I think my cats are cute too. All right. We're going to talk about why data sufficiency is so hard. In the chat, I want to know who here finds data sufficiency challenging. It is. I know when I started on the GMAT, I was coming from a background of SAT and ACT, right? And SAT and ACT, we've got problems that are more like problem solving, right? They've got 5 answer choices or 4 answer choices, and you pick one, right? It's a pretty straightforward question type. And data sufficiency is not straightforward. Data sufficiency is weird. And that weirdness comes from its unusual format, right? It comes from the fact that this problem is structured in a way that you don't see on other exams. Probably the closest we get is on the GRE with quantitative comparison. And even that is different from data sufficiency and slightly less complicated, in my opinion. Snoopy's123 says not challenging, but the hard ones can be time consuming. Yeah, absolutely. Data sufficiency can take time, especially if we don't have our strategy totally locked in. If we're approaching each one differently, we can get caught up in a lot of mistakes that eat time. All right, so let's really quickly just review the data sufficiency format just to make sure that we're all on the same page. So in the chat, if you feel confident with the data sufficiency format, you get it, give me a smiley face. If you're going, I don't really get this, maybe I'm newer to the test, give me like a sideways face or a frowny face, something to express maybe not 100% confident. And while we're expressing how confident we feel with just the format, understanding how these questions work, we'll just do a quick walkthrough of how these work. So essentially, the way data sufficiency questions work is they are about sufficiency. And what that means is how much information is exactly enough to answer the question. So if a statement is not enough to answer the question, and what that means is it gives us more than one answer, that is insufficient. All right. So if a statement gives us more than one answer to the question, insufficient. If a statement gives us exactly one answer to the question, it is sufficient. All right. Now, sometimes we get in a situation where we go, well, give me all the information, right? I want as much of it as possible, and that'll help me answer the question. That can get us in trouble because sometimes we take both statements when we only needed one. We could get to exactly one answer with only one statement. Or sometimes we take both statements and it's still not enough. We're still getting multiple answers. All right, so sufficiency it's challenging, right? So when we are working through data sufficiency questions, it's important to be aware that a lot of the mistakes come from the nastiness of this format, come from maybe not 100% understanding sufficiency and not doing a strategy, having a process for working through these questions that uses this format to our advantage, or at least understands this format and takes it into account. So we'll talk about that as we go through. But for the record, the way these problems work is we have a question stem. The question stem is a question that we cannot answer at this point. The question stem is never sufficient on its own. Know that. Then we have 2 pieces of information. all right? And those pieces of information individually might be enough to answer the question, get to one answer, or they might not. Sometimes we can put those statements together to have enough information to answer the question, or sometimes we still won't have enough information. We have the same 5 answer choices for data sufficiency every single time. First answer, A, is that statement 1 alone is sufficient. We can get to one answer using statement 1, but statement 2 is not sufficient. We cannot get to one answer with just statement 2. B is the opposite. It says with statement 2, sufficient. We can answer the question with that one alone. Statement 1 alone cannot. We will get multiple answers. All right, I'm going to skip to D. All right, D, the 4th answer choice, says statement 1 alone is sufficient and statement 2 alone is sufficient. We don't need to combine them with each one by themselves. We can answer that question, get to one answer. All right. So those are where our statements are doing some heavy lifting. But what if neither statement is sufficient on its own? Then we put them together. If that is sufficient, both statements to answer the question, our answer is C. So that says, I can't do it with just statement 1. I can't do it with just statement 2, but with both of them, I can. I can get to one and only one answer. And then our last answer choice is E. So if we process of elimination our way down, we pick E, which is, hey, even if I have both statements, not sufficient, can't do it. Okay, hopefully we're feeling okay. I'm gonna go through some strategies as we go that will help make this easier, but hopefully we're feeling okay on this format. All right, so it's a weird format, right? We've never seen this before coming into the GMAT. You may have seen it before now because you've been studying, right? Now, this format lends itself to specific mistakes. You can probably already see what some of those mistakes are, just not really knowing how it works, right? That's an easy mistake. So it lends itself to specific mistakes if you're a beginner and you're not super familiar with the format, but also if you're more advanced. These mistakes are still very easy to make, and there's kind of a spectrum of mistakes that you can make with data sufficiency. The beginner mistakes, the rookie mistakes, and the more carefully laid traps that take advantage of that format. So what we want to do is we want to appreciate this deserves specialized attention because this is unique to this exam, and it is 50% of quant questions. So it is worth our time to familiarize ourselves with these mistakes so that we know I need to be looking out for that, so we can avoid these traps that most test takers are going to fall into. So if you're here, you are putting yourselves at an advantage over test takers who are not considering these sorts of mistakes. All right, so today we are going to learn 5 of the most common data sufficiency mistakes. These are ones that I see my students make all the time. I saw them when I was teaching live classes. I've seen them when I'm doing live streams. I've seen them in tutoring. They are extremely common. And then we're going to learn how to avoid each one. All right, we'll start with our first mistake, which is one of the most common mistakes, especially for folks who are more recent in their study, which is jumping to the statements before working with the question step. Now, this is an easy mistake to make if you are new to these problems, but it's also really tempting to do down the line because when we look at a problem, the statements are the exciting part, right? They're the part that comes up in the answer choices. So it's really, really easy to go straight to statement 1 and go, I can do math on that, or I can start interpreting that. But the problem is that statement 1 isn't the first thing in the problem. The first thing in the problem is the question stem, the information that we know to be true, and the information about what we're solving for. You would be amazed at the number of people who jump into the statements without first knowing what question they're trying to answer. So what I see a lot of times is that students jump right into the statements. They spend a bunch of time on them without appreciating, 1, what they're solving for, but 2, what information they already have. And oftentimes the secret to the problem is lying in the question stem, in that information we already know. We're not considering whether it's sufficient. We know it. So we want to start with what we know already before we go into the statements, the stuff that we're considering whether we need it. So questions to ask yourself before moving on to the statements. And I generally say you can spend up to 30 seconds processing the question stem. Sometimes it'll be less, sometimes it's easy, but sometimes it's not. Sometimes it's a word problem. I saw that come up in the chat. Sometimes there's a diagram. Sometimes there's a lot of information. Spend time breaking that down. So really important. What is the question target? What am I trying to solve for? Is it X? Is it Y? Is it X squared? Is it Y squared? Is it X squared minus Y? What is it? All right. Appreciate what it is so you know what you're looking for sufficiency on. What information do we already have? Do they tell us X is positive? Do they tell us X is not 0? Those are important pieces of information, right? So make sure that you know that before you start making assumptions or not making assumptions going into your question stems. Going into your statements. And then finally, can we make that information we already have easier to work with? So if they've given us an equation, all right, can we make that equation simpler? Is there anything we can do to take that equation down and take it from, 10 terms to 2 terms, right? That's going to make it easier to process, and it's going to set us up more for success with the question. So take your time with the question stem before moving on to the statements. It'll help you go faster, and it'll help you get problems right. All right, we have got our first problem. Now, I don't want you to answer it quite yet. I want you to take about 30 seconds and start processing the problem. So specifically processing the question stem. And what we'll notice here is that the question stem includes text, but it also includes a diagram. So take about 30 seconds and then we'll come together and work through this one as a group. All right, so only giving you 30 seconds because we're just trying to process at this point. Let's start with our diagram because it's the first thing on the page. What do we notice about this diagram? And it's a specific geometry term that I'm looking for here. What do we notice about this diagram? In the chat. I'm not looking for answer choices. I'm looking for what do we know about this diagram? What do we notice? Maybe what's the relationship between the triangles? Yeah, Vedanta's got it. Vishal's got it. They are similar triangles. So yes, they are triangles and they are right angle triangles. That's awesome. But they are similar. Yeah, okay. So a bunch of folks are giving me that information. I'm also seeing 30, 60, 90. That's true, but we don't know that yet because we are supposed to have not looked at the statements. Ignore those. Ignore the statements. Looking at the diagram alone, though, we can tell that these right triangles are similar. So we've got a small triangle, ABE, and a larger triangle, ACD. Now, those triangles both have let me use my trackpad to make this a little bit easier for me to do. They both have a right triangle, right? So they both have 90-degree angles and they share this angle A. So that means they've got 2 of the same angles. Well, that means that we know that this third angle for both, and I actually want to change my pen color really quickly. I didn't think through the fact that I would be writing on a white background. All right, let's move over to red. Let me know if that's clear. We know that these 2 angles are the same. So we know that we have similar triangles. Okay, that's the first thing we should be processing. Well, what does similar triangles mean? Well, it means that our smaller triangle is just a scaled down version of the bigger triangle, which means that our sides have a relationship with the corresponding side. So that means if I know the length of AB is X, that means the length of AC is something that corresponds to it. Let's say it's 3 times the width, it'd be 3x. Well, that means if AE is y, that would mean AD is 3y. Or if BE is z, CD would be 3z. There is a consistent ratio relationship between the sides, but we don't know any of those lengths yet. And we don't know what that relationship is, but we know they're similar at this point. Okay, cool. We've taken care of the diagram. We're not ready for the statements yet. We still have to process the text. Okay, if B is the midpoint of AC. Okay, so we see B on our diagram. It is the midpoint of AC. Okay, well, what does that mean? And Ramon's got it. Okay, if B is the midpoint of AC, that means AB is X and BC is X, making B exactly in the middle, which makes the length of this longer side 2X, which means the relationship between the lengths of the sides of the smaller triangle and the larger triangle is 1 to 2, a factor of 2. So now we can apply that relationship to our other side. So if AE is Y, that means AD is going to be 2Y. And if BE is Z, CD is going to be 2Z. Beautiful. A lot of work has happened so far. We're still not done. What are we looking for? We are looking for the length of BE. So let's find that. We are specifically looking for this. Oops. No, we are specifically looking for, sorry guys. My slideshow got a little messed up. I'm going to write that back in. We're specifically looking for the length of that side that we called Z. All right, so we know here that CD is 2Z. All right, I'm not going to write in the rest. We're going to hope for the best. Okay, so we know at this point from processing all of this information, all right, we are looking for Z, and we know that CD is 2Z. We know we have similar triangles. All right. Now we're ready to jump into the statements. Let's start with statement 1. And I like to, on my scratch paper, draw a line between statements 1 and 2 where I'm doing my work to make it really clear which statement I'm working on. All right, so statement 1 says BAE is 60 degrees. So that tells us this angle here is 60 degrees. Cool. All right, which some folks in the chat have already mentioned this, means that these angles over here have to be 30 degrees, which means, oh, we got a 30, 60, 90 triangle. How great. Is that sufficient to tell us the length of Z? In the chat, yes or no? Can we determine the length of Z if we know that this is a 30, 60, 90 triangle? Yeah, awesome. Angles are never enough to determine a length or an area exactly, 255 SDR. Yeah, so a bunch of folks are getting this. So this is helpful. It can help us determine the relationship between the other sides, right? It can tell us that we've got, okay, X, X, 2X, and X root 3 as our side ratios, but it doesn't tell us the actual value of those sides. So we can determine, okay, statement 1, not sufficient. We can roll out A and D. And again, this was a lot easier because we understood what we were working with here. We need an actual length going on. All right. So then we go to statement 2, which tells us CD is root 12. Now, it's really tempting here to go, so now I have one of my lengths, and I can combine that with the fact that I know my side ratios, 30, 60, 90, and I can find all of my side lengths and use my ratios, and I've got it together, and the answer is C. But wait, which side does it tell me? And what am I solving for? This tells me CD is root 12. That means that this 2z length is root 12. That is the side that is associated with the one we're solving for. Remember, we are solving for BE. We don't care about the other sides. I don't care the length of AE or AB or AC or AD. It doesn't matter. I care about BE. Remember what you're solving for. So I know BE is Z, and I know CD is 2Z, twice the length, which means that Z is going to be half of that, or root 12 over 2. Oops. Which means statement 2 alone is sufficient, and the answer is B. All right, so what did we learn from this question? 1, we need to process the information we are given. There was a lot in this diagram and in the question stem, the written portion, right? We learned all the similar triangle stuff from the diagram, and that B is the midpoint of AC piece of information was absolutely critical for determining the relationship between our similar triangles. But also important here, we needed to remember what we're solving for. If in our heads we were like, okay, I need to find all the lengths of the sides, we would have thought that we needed both statements together. We would have thought the answer was C. But because we remembered I am solving for BE, that told us that CD alone was enough. I did not need to know the relationship between the sides because I knew the relationship between BE and CD. All right, so remember, process your question stem. It is important. Do it before you go to the statements. All right. So that is mistake number 1 and tip number 1. And I've got a question. What is the difficulty level of this question? I have picked questions that are all medium in Magoosh. So what that means is they're probably in high 500s, low 600s. Some of them might span a little harder, might span a little easier, but they're meant to be about where the median student is. So I would guess around the 600s. Wanted to pick things that clearly demonstrated and didn't rely on super challenging math concepts. All right. But these mistakes can be made on all sorts of levels of questions. So lower, higher, the mistakes are the same. All right. Data sufficiency mistake number 2, jumping to combining the statements before evaluating each one individually. Now that's a trap that we could have fallen into in that question that we just did, where we look at the statements, we go, I've got an angle, it tells me 30, 60, 90, I've got a length, I can combine those to find the lengths of all the sides. But we don't need it, right? We only need to determine BE. So this is a mistake that often comes in conjunction with some of our other mistakes. Jumping to combining and jumping to picking. I saw this in the chat earlier. C. We love to pick C. Test takers pick C a lot. We want to pick C like half of the time, but it is just as common an answer as A, as B, as D, and as E. So we want to be really careful that we are not immediately jumping to putting them together, and we're first processing each statement individually. So how we can do this, we are going to eliminate answer choices as we go. All right. So previously, when we did the last question, when we said statement 1 is insufficient, we crossed out A and D because we knew those answers were no longer relevant to us, but we knew B was still on the table. All right. So a good process of elimination with your answer choices here helps you avoid this sort of mistake. Again, very dependent on the format, the structure of the question. So I've been kind of hinting at this, but this is a good rule of thumb. If you are picking the answer choice C before you have ruled out, crossed out A, B, and D, you are making a mistake. A really good tip that I have is on my scratch pad, I like to make little columns for A, B, C, D, and E when I'm doing data sufficiency. Draw those lines down my paper, and then I cross them out down the columns as I go through individual questions. That helps me ensure that I'm following the same process of elimination for every question, and I'm not accidentally skipping to combining the statements before I've processed each statement individually. Hot tip. Now, another hot tip. You do not have to evaluate first statement 1 and then statement 2 and then put them together. You can start with statement 2. That's okay. If statement 2 is easier, in fact, I recommend it. But just make sure that you are adjusting your process of elimination accordingly. So if you start with statement 2 and it is insufficient, you will roll out B and D. If statement 2 is sufficient on its own, you will roll out A, C, and E. So it's not that hard to be able to start with either statement. Just make sure you're adjusting your process of elimination accordingly. Start with one statement alone, move to the other statement alone. Only then should you put them together. All right, and that helps avoid mistakes where you should be picking A, B, or even D, but instead pick C. Classic mistake, super common. Let's take a look at a question. Okay, again, we're going to take 30 seconds just to process. And I want to give the advice here. Is there anything we can do with our question stem? Anything we can do to make this a little bit easier for ourselves? Take 30 seconds. I don't want to see any answers. And then we'll come back together. Okay, so what do we notice about what we're solving for? So we're being asked to solve for x squared minus y squared. What do we notice about that? I'm seeing some folks saying use of identity, factorize the expression, and they're absolutely right. Does anyone know the specific name for this? X squared minus y squared. There's a specific term for it, a math term that I've got in my head. Does anyone know what that is? In the chat. It's a good one to know because it comes up. I'm not seeing it. We've got a binomial. Yeah, it is a binomial, but specifically this is nice. Here we go. Sunday and Sanjay have got it. It's a difference of squares. And if you don't know what a difference of squares is, it's where we have two squares subtracted. And if you don't know that, that's okay, as long as you know how to factor it. This is just a classic binomial, classic form of polynomial. So when we have a difference of squares, this always factors as x plus y times x minus y. So the base of the first one plus the base of the second times the base of the first one minus the base of the second. So when we see difference of squares, we should consider processing it and putting it in this form, because often we'll want to use it in the other form. Okay, so we've processed our question stem. We're going, okay, we might use it in its original form, x squared minus y squared, but we might also use it in its factored form, x plus y times x minus y. Okay, let's move on to our statements. Again, keeping in mind, we need to process them individually. Now, what if we didn't do that? What if we didn't take our time to process each statement individually? We might go, oh, I'm so clever. I factored this out. Difference of squares. I've got an x plus y. I got an x minus y. Statement 1 gives me an x plus y. Statement 2 gives me an x minus y. If I put them together, I've got both pieces and I can solve. The answer is C. Right? Hold on. We would just have picked C without first eliminating A, B, and D. Don't do that. We don't want to do that. All right, so we're going to go rewind. Let me process each statement individually. Be sure. Cross out A, B, and D before I pick C. Okay, so let's first process statement 1. This tells me that x plus y is 16. So I can plug that into my equation and I get 16 times x minus y. Well, I still don't know what x minus y is. If it's 2, my answer is going to be 32. If it's 1, my answer is going to be 16. I have no idea. So statement 1 alone is insufficient. Sorry, I'm having some trouble with my slideshow. Insufficient, and we can rule out A and D. All right. Now let's move on to statement 2. Now with this one, x minus y equals 0. Well, let's plug it in. So we've got x plus y times x minus y. Well, we don't know x plus y, but we know x minus y is 0. Oh, wait. I don't know what x plus y is, but it doesn't matter. If x plus y is 1, 1 times 0 is 0. If x plus y is 16, 16 times 0 is 0. If x plus y is a million times 0 is 0. If x plus y is negative a million, x plus y times 0 is 0. So this statement is sufficient because it will be 0 regardless. So statement 2 tells us the one and only one answer is 0, and the answer is B. So what did we learn? Here it would have been really easy once we process the question stem to go, I need an x plus y and an x minus y. I get that in statements 1 and 2. I can put them together and the answer is C. Booyah! And we think we did it because we did that really cool thing where we processed the question stem. But it was too easy, right? So we need to first go through the motions and individually process the statements to ensure we don't fall into a trap. So here, the fact that it was 0 is what made statement 2 sufficient, and the answer B. All right, moving on to mistake number 3, which is forgetting to consider edge cases. So the previous 2 questions were a little bit more just our process, right? How we get through this type of question. Now we're getting into the question content itself. And I saw this in the chat earlier that sometimes we forget to consider all of our cases. And that is exactly what this mistake is, where we think, we go, okay, well, it seems like it's sufficient because if I try all the numbers I can think of, it's sufficient. Or if I try the most obvious numbers, I get the same answer. But sometimes we forget to try the weird ones, right? And it's the weird ones that break the problem. So for instance, on that last problem, the only reason B was sufficient was that it equaled 0, right? If it equaled any other number, it wouldn't have been sufficient. 0 is a common edge case. It's a common weird one that we need to consider when we are trying these problems. So what I want to share is do not make assumptions, and specifically, do not make assumptions when it comes to specific categories of numbers and common edge cases. So when you are determining if something is sufficient, I advise you to think about positive versus negative versus 0. We might get one answer with a positive number and a different answer with a negative number, or 0 might swoop in and be the thing that makes it insufficient. So consider your categories of numbers. If you do not know that a number is positive, you need to consider whether it is negative or 0. Similarly, consider integer versus fraction. This one's really common. Often we look at a problem and we go, it has to be this, because if I'm thinking of only numbers like 4, 5, 6, 7, 8, we get the same answer. But what about 4.2? Or what about root 5, right? We have to consider fractions. If they don't tell us, we don't have them. Similarly, even versus odd. Classic one that we see this in is with primes. Most of our prime numbers are odd, but there is one even prime. It's 2. So if you see primes, make sure you are testing 2. This is a classic mistake. It is an edge case, so consider categories of numbers. If you've only tested evens, try testing an odd. And there's more. If you tried only small numbers, try big numbers, etc., etc. If you tried only something that's divisible by 3, try something that's divisible by 2. If you've tried things that are not square roots, try things that are square roots. Or if you've tried only things that are not squares, try things that are squares. Make sure that you are considering the various categories of numbers. All right. Oh, and I'm seeing a great comment. We can never prove a case with number picking. You can never prove something is sufficient with number picking. You can get pretty close to make an educated guess, but you can prove something is insufficient with number picking. You can prove something is insufficient with number picking. If you get multiple answers, it is not sufficient, and you can rule out answer choices. So number picking is a good strategy if we keep that in mind. It can only prove something insufficient. Okay. Let's go ahead and try a problem. Again, keeping in mind our strategy that we need to consider edge cases. This one's a little harder. All right, take about 30 seconds to process, and then we'll come together to work through it. Okay, so hopefully we've had a little bit of time just to start thinking about it. But we'll notice for this one, there's really nothing we can do with the question stem. Is X greater than Y? That's as simple as it gets. Great. Okay. So we can imagine that probably I'm going to have to do more work with my statements. All right. So we're going to be really careful as we go into them. I'm going to start with statement 1 here. So taking a look at statement 1, we see this expression negative 4x, or equation rather, inequality. We have negative 4x plus 2y is less than y minus 3x. In words, in the chat, what do you think we should do at this point? Should we start picking numbers? Or what? What would be the best way, most likely, to approach statement 1? Just with words. What is the strategy? Yeah, let's work on this inequality. Let's simplify this sucker, right? Because we can. Let's get all of the like terms on one side. We know with inequalities, we can add and subtract till the cows come home. That is allowed. It doesn't do anything to our sign. We can add and subtract as much as we want. So rather than going in and picking numbers, because we know we can't prove something sufficient with picking numbers, let's just see if this simplifies, and then we can maybe start considering if we need to think about cases. So simplifying, I'm going to subtract y on both sides and add 4x on both sides. And I'm not going to show exactly how I do this just because I'm having trouble with my mouse pad, but we end up with y is less than x. All right, so subtract y on both sides, add 4x on both sides. We end up with y is less than x. And if we just flop that around, just spin that around, we see that x is greater than y, which is literally the exact same thing that our question stem asks. Exactly the same thing. We did our math right. We made no mistakes. It tells us the same thing. We do not need to consider edge cases because in every single case, it is exactly the same. So we know that statement 1 is sufficient on its own without having to consider edge cases. So we know at this point that our answer is either A or D. Nice. Okay. So far, this has been a little bit easy. Just bearing that in mind as we go into statement 2. All right. If we're going, I'm on a roll, all right, let me simplify statement 2. We might go, hey, I got W's on both sides, so I'm just going to cancel out the W's, divide by W on both sides, and I get X is greater than Y again. Nice, sufficient. The answer is D, right? That feels a little easy, doesn't it? What am I not considering? Well, a lock, we want to be careful. Statement 2 does fail if W equals 0, but we know that's not possible because statement 2 is true. We know that. So W cannot be 0. That is not allowed. But what if W is negative? Oh, wait. And this is where we might start to think about our rules of inequalities, right? Again, we can add and subtract on both sides as much as we want. We can multiply and divide by positive numbers as much as we want. But what happens when we multiply or divide by a negative? My side flips. So if W is positive, then I divide and my sign doesn't flip and I get X is greater than Y. But what if W is negative? If W is negative, when I divide both sides by W, my sign flips and I get X is less than Y. So if it's positive, my answer is yes. If it's negative, my answer is no. I get 2 answers. Statement 2 is insufficient on its own, which means I can rule out D and pick A. So we got 2 answers for statement 2, yes and no, which means it is insufficient. So we need to be careful. If things are feeling a little too easy, we need to consider edge cases. And when we have inequalities, our edge case is usually negative numbers because negative numbers flip signs. Now, if you weren't 1,000,000% sure here, you could have tried this by picking numbers. Tried it, plugging in 2 for W and -2 for W, and we would see, oh, that actually changes the relationship here. So consider your edge cases and know which edge cases are associated with which types of problems. For inequalities, it's often negatives. As I mentioned earlier, for primes, it's often 2, the even one. All right, so make sure you're considering your options. Okay, so we know to consider edge cases in both value problems and yes/no problems like this one. But yes/no data sufficiency problems like this one come with another trap. And this one's nasty. This one is common. Mistake number 4 is forgetting how sufficiency works for yes/no questions. So our first 2 questions were value questions. They asked, what is X? Or what is X squared minus Y squared? So our answer would be a value. So if we only get 5, it's sufficient. But if we get 5 and -5, ooh, it's insufficient, right? That's easier. Yes/no questions are a little bit nasty because yes is an answer. If we only get yes, it's sufficient. No is also an answer. If we only get no, that is also sufficient. The only way to get insufficiency for yes/no questions is to get both a yes and a no. And this is really tricky So let's talk through a couple of cases where folks will often say something is insufficient when it actually is sufficient. So, reminder, sufficiency is one and only one answer. So, if we have a problem, all right, and in that problem, multiple values can work, but they literally all give a yes, all right? Maybe x can be 5, but it can also be 6, but it can also be 7, but it can also be 8. If that gives a yes answer to the question, it is sufficient, despite it being multiple values, because the answer is yes, only one, all right? So multiple values doesn't matter as long as it gives the same yes/no answer. Similarly, oftentimes go, all right, I solved my problem and I was looking for x is greater than y, but it actually gave me x is less than y. So that's no, and no is negative. So that means insufficient. That's not true. If the only answer we get is no, that's an answer. It is sufficient to answer the question. The answer is no. And so that would be sufficient. All right. So with yes, no questions, a yes, even if there's a million of them, that is sufficient. A no, even if there's a million of them, that is sufficient. The thing to keep in mind here, if you get both a yes and a no, that is the only way to determine insufficiency. So my trick with yes, no data sufficiency questions is I need to have both a y and an n next to that statement. If I don't have both a y and an n next to that statement, I do not know that it's insufficient and I'm not ready to move on. Okay? So insufficiency is a yes and a no. This is a really common mistake. Let's try one. And you know what? I want to let you try this one on your own. So let's take, you don't need a whole 2 minutes on this one. Take a minute and a half. Try this one on your own and put the answer in the chat. And then we'll try it together. Now, keep in mind all of the previous mistakes, in particular for this one. Consider edge cases and consider what does sufficiency mean for a yes/no question. Good luck. Okay, let's come together as a group. All right, so taking a look at our question stem, the question is x greater than 5? And once again, there isn't really much we can do to work with that. That's about as simple as it gets, but we see that this is a yes, no question. Yes, no. So that means if I'm going to be picking numbers or going through this problem, I need to get both a yes and a no to prove that that statement is insufficient. Okay, bearing that in mind. I'm going to start with statement 1. And again, you could start with statement 2, but I'm going to start with statement 1. X is less than 6. All right, in the chat, if x is less than 6, what is one case? What is one number that x could be? In the And And a number of folks have figured out the trick with this one, but just give me a number that x could be in the chat based on statement 1. All right, we'll go with an easy one. Let's say x is 1, right? X is 1. All right, or x is even 4, right? Let's go x is 1. All right. All right, if x is 1, then x is not greater than 5. The answer is no. All right. Okay, now let's try to get a yes. All right, and a lot of folks are putting in 5. Well, x could be 5, and 5 is less than 6. And 5 is 5 greater than 5? That's also a no. So I'm getting a bunch of no's so far. Remember, that should be sufficient. But I'm also seeing folks in the chat go, wait, edge case, we haven't considered non-integers. So we have a bunch of numbers between 5 and 6 that it could be. So what if x is 5.5? Okay, all right. 5.5 is less than 6, but it is greater than 5. So that gives me a yes. So I have both a yes and a no, which means that it is not sufficient. I'm getting 2 answers. I can eliminate A and D. Okay, now let's take a look at statement 2. X is less than 4. Well, this seems pretty clear, right? X is less than 4. Any number that is less than 4 is going to be less than 5. If I do 3, that's less than 5. That gives me a no, right? If I do x is 3.5, that's still less than 5. That gives me a no. If I do x is 0, that gives me a no. If I do x is -3, that gives me a no. I get no's, 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 no's. Now, at this point, a lot of people make the mistake of going, no, insufficient. But remember, no is an answer. I got one answer. The answer is no. So statement 2 is sufficient because I can answer the question. The answer is no. So the answer here is B. So 2 learnings on this one. 1, no is an answer. If we get just no's, that is insufficient. 2, test edge cases. So with statement 1, if we just picked integers, we would have gotten a consistent answer of no, and it would have been sufficient. But because it does not tell us x is an integer, we have options like 5.5 that give us a yes, which is 2 answers, yes and no, making it insufficient. So remember mistake number 3, test for edge cases, and remember how sufficiency works with yes/no questions. 2 answers, yes and no. You need to get both to prove insufficient. Okay, awesome. Now we can see that some of these questions are combining mistakes, right? And that's where things get tricky because once we solve the first mistake, we can let our guard down, right? We go, ooh, I caught the edge case, nice. And then we might not catch in statement 2 that we have a bunch of no's, right? Or in our second question, we do that really clever thing with the difference of squares and we go, nice. And then we don't check. Oh no, I have to make sure to consider both statements individually. So make sure that you're not letting your guard down, which leads us to our final mistake. And this one is the big one. It's not asking what's the trap. And this comes down to a fundamental misunderstanding of how the GMAT works, and specifically how data sufficiency works. A lot of people think that standardized tests are tests of knowledge, and some of them are, but not the GMAT. The GMAT is a test of critical thinking, of critical reasoning, of problem solving. But it uses a foundation of math, of grammar. to test that. So a lot of people think, hey, if I've got the math, I've got it. No, every problem is doing something more than math. And in sentence correction, every problem is doing something more than grammar. It is doing an extra thing that is requiring you to reason. So really what the problem is testing is beyond the math. It's the trap and your ability to avoid it. So what we want to do on these questions is at every phase, if something feels a little too easy, we're going to go, what's the trap? What am I missing? What is this problem actually asking? Because if we're just doing math, we're missing the real problem. Yeah, it's logic. So if you don't see the trap at a given point in the problem, you're probably in it. All right. Definitely test my patience too. You're right. We need patience and we need critical thinking. So for every bit, be patient. Don't jump ahead. Don't get excited. If you're too excited, you're probably making a mistake. Go, what? What's the trap? Be patient. All right. Now this move, asking what's the trap, being critical, what is the test maker trying to get me to do right now, is going to help us avoid the previous 4 mistakes as well as other less common mistakes. So at every point, if something feels too easy, something feels too convenient, you're feeling too good about the problem, what am I missing? And that'll help you avoid these traps at every step. Okay, with that in mind, let's try one more question. And I'll let you try this one on your own. When you think you've got the answer, put it in the chat. Okay, we're going to come together. Some folks are asking what's the trap in the chat, which is great. Well, let's come together and figure it out as a group. All right, so let's talk through the mistake we can make on this one. So we look at our question stem. What is the value of X? Okay, it's not yes, no. Nice. It's a value question, a little bit easier. And there's nothing really we can do to simplify it. We're just looking for the value of X. No extra information, doesn't tell us much. Now, let's take a look at these statements together. Maybe that's a mistake, but let's take a look at these statements together for just a second. What does that make you think of when we have these two statements? There's a specific math term. When we look at those two equations, what do we think of? Two equations, two variables. Without looking at actually what the equations are. What's the math term? We got two equations. I don't even know. I'm seeing elimination. Yeah, so elimination and substitution are two strategies we use with systems of equations, all right? And simultaneous solving, yeah. So systems of equations is the term that I typically use for it, which is when we go, okay, if I have two variables, typically I need two unique equations to solve for those two variables. If I've got three variables, typically I'm going to need three unique linear equations to solve for them, right? So I'm looking at this and I'm going, statement one has an x and a y. There is no way I'm going to be able to solve for x because it's two variables, right? So insufficient. And that's true, right? Statement one is insufficient on its own. A and D out. I look at statement two on its own. Again, I go two variables. Well, two variables, one linear equation, except for in some weird cases, I'm not going to be able to solve that. All right. So I go insufficient on its own as well. B is eliminated. And so far, we haven't made a mistake. Here's where we make a mistake. We go, I've got two linear equations, two variables. I know that I can solve for x because two equations, two variables, I can do it. And so I go, I'm saving some time. Nice. I know I can solve for x. The answer is C. Right? That was smart. I saved time. That was too easy, right? That was too easy. Where was the trap in that? There wasn't one. Uh-oh. Uh-oh. So I'm going to stop and I'm going to go, wait, hold on. What am I missing? Because that was too easy. And I am seeing folks in the chat saying, both equations are the same. And yep, they're the same. Andrew has that one as well. And I saw some other folks in the chat with that same thing earlier. So when we go, hold on, wait, there's a trap here and I'm missing it. We might take these equations and start to simplify them, start to take them down. And we see that in statement one, we've got a common factor of 2. So we've got 3x minus 7y equals 5. In equation 2, we've got a common factor of 3. So we divide by 3, 7y equals 3x minus 5. And I'm going, wait, hold on. Those are the same numbers. Uh-oh. So if I rearrange this second equation, I end up with 3x minus 7y equals 5. So I don't have two variables and two equations. I have two variables and the same equation. I cannot solve this. There's the trap. So even with both statements together, I can't solve. The answer is E. So if things are going too smoothly, if you're going, nice, I'm nailing it, pause, hold on, because that is a dangerous feeling and the test maker wanted you to feel it. So we are going to go, what's the trap? We're going to pursue that. And that's going to help us get to the right answer and avoid a mistake. So we can avoid all of the previous mistakes and a weird mistake like this one. And the more problems we do, the more we're going to start recognizing those specific mistakes. So with inequalities, we're going to start going, wait, hold on. I need to check for negative numbers. When we see systems of equations, we go, wait, hold on. What if they're the same? All right. So we need to pause. When we see problems where they don't specify integers, we go, wait, hold on. I need to check for my decimals or my fractions. All right. So as we practice, we're going to see more of the more specific mistakes that come with certain types of math. All right. So those are our 5 most common data sufficiency mistakes. So to review, jumping to the statements before working with the question stem. Sometimes we don't have much in the question stem, like the last one, but sometimes we have a bunch, like in our first 2 questions. Process what you're working with. What do you have? Can you make it easier? And what are you solving for? Because if you're not solving for the right thing or you're solving for too many things, you might get the wrong answer. 2, jumping to combining the statements before evaluating each one individually. A little bit different than what happened on that last problem, but we need to make sure that we have rolled out A, B, and D before we even put together those statements to consider C. All right, process each statement individually. Forgetting to consider edge cases. So forgetting about negative numbers, forgetting about non-integers, forgetting about our one even prime, forgetting about perfect squares, forgetting about all of those weird numbers, forgetting about 0, right? Forgetting about 1, forgetting about the weird numbers that make things different. Oftentimes, a bunch of answers will give us, or a bunch of values will give us the same yes or the same no. But if we put in one weird value, it'll change the game and give us a different answer. So always consider edge cases. Forgetting how sufficiency works for yes-no questions. So remember, the only way to prove a yes-no question insufficient is to get both a yes and a no. You need both. If you have a million yeses, sufficient. If you have a million no's, sufficient. If you have one no, sufficient. If you have one yes, sufficient. If you have both a yes and a no, insufficient. And then finally, not asking what's the trap. This can help you avoid the previous 4 mistakes as well as other weird ones. So we always want to consider, what are they doing here? Because this problem is not just math. It's logic. It's problem solving, it's critical thinking. So at every step, ask what's the trap and avoid the mistake that other test takers are going to be making. Okie dokie, that is it for our 5 most common data sufficiency mistakes. And again, if you want to see more of me, you can check me out at Magoosh GMAT. You can check out our YouTube channel, Magoosh GMAT. You can also subscribe to GMAT Club. I'm here relatively often. And you can also check out Magoosh GMAT if you are looking for some more dedicated GMAT prep. We've got self-study options. We got some live classes. We've got a bunch of stuff, all created by test prep experts like me who know this test inside and out. So if you're looking for some more dedicated study, check out Magoosh GMAT. Okay, ooh, we got a question from a lot. Could be true questions trouble me a lot. Yeah, could be trues are tough. Could be trues are nasty. Fortunately, they're not particularly common. All right. I like to approach could be true questions kind of like data sufficiency, where I am testing cases, right? I'm considering the logic here, and critical reasoning is very much the same. And once you think about those as logic questions, I think they become easier, where we are considering cases. Could be true means there is even one case where it's true, even just one. So that means we're often testing the weird cases. We're testing those edge cases. All right. So when you're thinking of could be true, think of it a lot like when you're testing cases for data sufficiency, and think about the weird ones. All right. What are the weird cases? What could possibly make this true even one time? The other thing that I'd consider with could be true is that if it is giving you so much grief, don't spend too much time on it. Move on. Make a guess and move on. Eliminate some answers if you can, but move on. Because, and I talk about this a lot, but the way the GMAT works is that it adjusts your difficulty to the difficulty where you are missing about half of the questions, regardless of how well you're doing, unless you're at the very, very, very tippy top or the very, 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 very bottom percentile of test takers. Regardless of how you are doing, the difficulty will be adjusted so that you are missing a lot of questions, a ton of them. So missing one question is not, and by missing, I mean getting it wrong. Getting a question wrong is not a big deal. It's not. It is something you can expect to do on test day. So a really good strategy is targeting which questions you're going to miss. If a question is, or get wrong, if you are going to spend 10 minutes on that question, just get it wrong already. Because if you're going to spend 10 minutes on it, you're going to get other questions wrong later, or you're not going to get to them later because you just don't have time. So if something is giving you that much grief, consider just guessing and moving on, eliminating what you can, and go forward. Hopefully that's helpful. All right. Got a question from Ezio. How close are the OG questions to the actual GMAT in terms of difficulty? So yeah, really great question. OG questions are the gold standard. They are the best of the best, right? I think Magoosh questions are great, but OG questions are the best because they come from the test makers. And oftentimes OG questions are questions that were previously GMAT questions that have been taken out of the rotation. So if you are looking for the best of the best, I say OG. However, there's an issue with OG questions. And the issue is that they're not often sorted as well as they could be. So if you're just going through a book of OG questions, who's to say what difficulty you're working on? Now, if you're working in their online portal, you can often select what's easy, what's medium, what's hard. That's going to be pretty dead on to what's easy, medium, or hard in the test. But if you're just going through a list of questions, I mean, it's like a question on the test, but there's a ton of difficulties on the test. So that's where something like Magoosh or another program can be really useful, is that we can target those questions. We can say, okay, here are easy questions. Here are medium questions. Here are hard questions. Here are very hard questions. And we've sorted those for you. We can also sort those questions so that you're working with specific question types, right? So instead of just going through a random bundle of questions, you can go, no, I want to work on algebra. I want to work on geometry, and I want to work at a medium to hard level. And then you can practice that very specific group of questions. So that kind of leads me to how I recommend using OG, which is as a test for yourself. If you're just doing practice problems, right? If you're just trying to learn a concept, I often recommend using something like a program like Magoosh, right? Where you can customize that practice, right? And you're not going through your very limited bank of OG questions. Now, when you're looking to test yourself, you're looking to do timed drills, or you're looking to do a practice test, then I recommend OG as much as you can, because it is the most realistic to what you will actually be doing on test day. So for customized practice, I recommend something like Magoosh. For testing yourself on what you learned in that customized practice, OG. Hope that's helpful. When do I have to put the results from an equation back into the equation to test if it works? That's a good question. It's a good practice, kind of across the board. It's a good little check, especially if you're going, wait, what's the trap? Then I would try something like that. But a case that I would really, or a couple cases that I would really, really recommend plugging back in just to check, just to confirm. Square roots, square roots, really important one. Because sometimes we'll solve a square root equation, and then when we put it back in, we end up with like the square root of a negative. Test that. Similarly, like absolute value, that's a weird one. So anytime you're doing like weirder math, and by weird I specifically mean square roots or squares or absolute values, you might just want to check to confirm. Similarly, if you're doing any math where you think you might have done something wrong, it might be worth checking. So if you know that you make mistakes on inequalities, that's a big one for me. I make mistakes on inequalities. I don't know why, but it's just I make mistakes. I'll often check to confirm that I did the math right. And then if it comes out something strange, then I go, maybe I made a mistake. So there are problems where sometimes you get an answer that doesn't work when you plug it back in. Common cases, roots, squares, exponents, absolute values, check those by plugging back in. And then anytime you're not confident in your own math, check by plugging back in. My exam is scheduled for the 17th. I was struggling with DS till today. This session will undoubtedly benefit me. I'm so glad. Really, with DS, there is math. Math is the foundation, though. It's logic. What's the trap is my biggest strategy for data sufficiency. And the other one is having a process. Do the exact same thing on every single problem. I have a way I write these problems. You saw I was writing 1, 2, and I was doing X's and checks and Y's and N's and crossing things out as I go. That's because that's my process. Drawing a line between my work for the statements, that's my process. I do that every time. And because I do that every time, I don't make those mistakes. All right. So come up with a process that works for you that you can follow every time for data sufficiency, and you'll make less mistakes. All right. SEO says OG 2022 has the split of easy and medium, but not hard. So I guess for hard, it's best to use another material. Yeah, there is online in the bank of questions that comes with the free practice test. There's like a bank of 90 questions. There are some hard questions in there that you can practice. But the big thing that I would note, and I'm not trying to like discourage you from trying Magoosh because I think Magoosh is great, is what's your level? Because if you are scoring in the 500s or like the lower 600s, medium questions are probably really appropriate for you. And that's maybe where you should be practicing. If you're not scoring in like the high 600s or the 700s, maybe you shouldn't bother with those harder questions because you won't see them on test day because, again, they cater the questions to your level. Now, if you're worried about running out of official questions, then yes, maybe I would experiment with another source. But my big piece of advice is cater the difficulty of questions you're practicing with to your personal difficulty. And you can determine that based on how you're scoring on your practice tests. Tip. All right. Okay, my current scores are quantitative 46 and verbal 33. Should I do quant first or verbal first? Okay, well, first let me remind. Well, here's what I'll tell you, because the percentiles are not coming off the top of my head. Raw scores don't matter. Look at percentiles. All right, look at your percentile for quant. Look at your percentile for verbal. One of those is going to be lower, most likely. The one that's lower is the section that needs most attention. However, for most of my students, I recommend quant first. Most students. Unless they're way, way lower in verbal and really, really struggle in verbal, I recommend quant first. Because like we saw today, quant is finicky, right? There are little things where if you don't do them right, or if you miss them, you will miss the question. You will get it wrong. With verbal, it's a little more flexible, right? With verbal, there are fewer little mistakes you can make. It's more about your overall understanding, your overall logic, your overall process. All right. It's less about the little things like, oh, negative, or I just did a small mistake. So typically I recommend quant first because you're most alert when you start, right? You're most likely to not make those little mistakes. And then when you're a little sluggish, you're maybe a little bit making more mistakes, that's when I recommend going into verbal, because there it's easier to get the questions right, even if you are a little bit slower, a little bit more error prone. So for most students, I recommend quant first. There's some rare cases where I'll recommend verbal first, usually like if a student is really nervous about it. But generally, I recommend quant first. Another thing to consider is if your school like particularly cares about one section over another, then it might be useful to value that one a little bit more. Like if your school only cares about quant, definitely go quant first. But yeah, I'd say 90 to 95% of the time I say quant first. Okay, I think we are through our questions and I have to run, but thank you so much for being here today. I hope that this was helpful. If you have further questions, you can leave them in the comments on this video and someone from GMAT Club might be able to help you. All right, thanks so much for being here. I'll see you later. Bye-bye.